All right, today we're going to be talking about attributes of functions. We're going to start with linear functions. You're used to seeing this as y equals mx plus b, but remember that the y is just f of x. So we can say xy, or we can say x f of x, and it means the same thing. So what are m and b? M is slope, and b is y-intercept. So when we look at slope, recall that it is rise over run. So we count the steps that it goes up and then the ones that it goes over. So our slope here is 2/3. The y-intercept is where it crosses the y-axis. So here our y-intercept is at 0, -2. The x-intercept, so we can see, our equation then becomes y equals 2/3 x minus 2. And we can put all that in the equation. The x-intercept is not articulated in the equation, but it's where it crosses the x-axis. So here it's at 3/0. Note that every point on the graph is described by this relationship. We can pick any point. So if I were to pick 9, 4, I plug in 9 for my x. 9 times 2/3 is 6. X minus 2 is 4. That equals 4. So that makes it into a true story, okay? Same thing, I plug in 0 for x. That goes away, I get -2 equals y. It makes it true. That's what the equation does. Now, looking at it in different ways, here's another example. The slope of this guy, if we do rise over run, pick 2 points that are on the grid, and you can see that it goes down 1 over 2. So this slope is -1/2 because it's as x is increasing, y is decreasing. They're doing opposite things. Over here, as x is increasing, y is increasing, so that's a positive slope. Our y-intercept is at 0, 2, and notice that our y-intercept has x equals 0. This is always true. Every y-intercept since the beginning of time. Our x-intercept, this one is at 4, and it has y equals 0, which again is always true. Every x-intercept has y equals 0 since the beginning of time. Domain and range, we have a mnemonic, DRXYID, where we say Dr. Exy is very sexy when she wears her ID. That means domain is the x values, range is the y values, x is independent, y is dependent. So the domain are all the x values that work for the equation. So because this goes on and on forever in both directions, I know that my domain is all real numbers. Okay? The range of values, by the same token, it's going to go up to infinity, up to infinity, down to infinity. The range is also all real numbers. Okay? These are true for every linear function without restrictions. Okay? Every linear function has those things true. Okay? We can look at it in a table. So the first thing we want to check when we're given a table of data is, do these have the same difference of x values? If they do, it makes things easy. If they don't, it's possible, but it can still be done. So I look at the change in values for each of these, and I notice that from -3 to 0 is 3, 0 to 3 is 3, 3 to 6 is 3. So it goes up by 3 each time. So it does have the same difference. That's nice. Again, it makes it to where things are much easier and more straightforward. 8 to 4 is going down 4, so we say -4. 4 to 0 is -4. And this last one should say -4. And this one is also -4. So slope is just rise over run, but it's also change in y over change in x. Okay, so whatever our change in y is divided by our change in x, this is our delta y, and this is our delta x. So for any one of those, it's always -4 over 3. That is our slope because they're all the same. Remember, the y-intercept is where x equals 0, so that's at 0, 3. The x-intercept is where y equals 0, So that's at 3, 0. Sorry, the y-intercept is 0, 4. Okay, so this one goes here, and this one goes here. There we go. Lastly, we can look at it as an equation in standard form. Standard here means kind of usual or basic. Not really our standard form. We prefer slope-intercept. So in order to get there, we have to solve for y. Because we want to get it into y equals mx plus b form to be able to see the slope and the intercept. So first step, I subtract 5x. That's going to give me minus 2y equals minus 5x plus 10. Next, I divide by the thing that's in front of my y, so divide all of them by minus 2. That's going to give me y is equal to minus, no, sorry, that's plus, because it's minus 5 divided by minus 2, so minus 5 over 2x minus 5, because it's plus 10 divided by negative 2. Well, there is y equals mx plus b, easy as can see, so this slope is 5 over 2. My y-intercept is 0, 5. Now to find the x-intercept, we recall that every x-intercept has y equals 0. So I'm going to set y equal to 0 and then solve. So I'm going to take my original equation, 5x minus 2 times 0 equals 10. So that term goes away. I get 5x equals 10. So x equals 2. So my x-intercept is at 2, 0. There we go. So that's all about linear equations. Let's consider quadratics now. So the thing that makes it quadratic is if it has the squared term. Any graph that has the squared term in it is a quadratic for our purposes. And those graphs are in the shape of a parabola. Bobby Brown wrote a song about that. Y-intercepts and x-intercepts are still the thing. It's just wherever it crosses the axis. So my y-intercept here is at 0, 8. My x-intercept, this one is at negative 4, 0. And this one is at 8, 0. Okay? The vertex is where it changes directions. So it's been going up this whole time. It hits this point here, and then it starts going down. That's our vertex. So the vertex is here at 2, 9. That's our vertex. The maximum value, so as we just said, it was going up and up and up until it hit this maximum value, and then it goes down. Our maximum value is y equals 9. And you will notice that the y-coordinate of the vertex is also the maximum value. The last thing we talk about is the axis of symmetry. Remember, symmetry means everything on one side of the line is the same as the other. And our axis of symmetry is also the x-coordinate. So x equals 2 is our axis of symmetry. Okay? You can pause before we do each of those and try to get these yourself before we go on. Or I will just work them. So here we go. If we look at this graph, and we're going to assume, for the sake of our analysis here today, that this graph goes on and on forever in this direction and in this direction. All right? So, first of all, what is our vertex? Our vertex is at 25, 350. The axis of symmetry, recall, it is the x-coordinate. The axis of symmetry is x equals 25. This has a maximum value. That maximum value is y equals 350, which again is the y-coordinate of the vertex. The y-intercept is at 0, 0. The x-intercept is at 0, 0, and 50, 0. And our domain is, again, we're going to assume it goes on and on forever. And if, for a quadratic function, for a parabola, there are no numbers which do not work. So our domain is all real numbers, and this is the symbol for all real numbers. The range, however, does have a limit. It begins at negative infinity, but then it goes up to the maximum value of 350. We could also write our domain as negative infinity less than x less than infinity for all real numbers. Okay? And for this last one, when we look at our vertex, there it is at 3, -7. The axis of symmetry is the x-coordinate, x equals 3. This one has a minimum value of y equals -7. The y-intercept is a little bit hard to see, but we'll say it's at 0, -5.5. Our x-intercepts are at -4, 0, and 10, 0. The domain, again, for any quadratic function, it's negative infinity to infinity. Our range, this one has a minimum value, so we put it in there. So -7 less than or equal to y less than infinity. And that is our range. All right, hope you enjoyed the notes for today. We will see you next time where we'll talk more about linear functions.